Welcome, everyone, to Building SaaS on AWS. I am your host today, Christopher Logan, and this is the show where we talk about innovations, best practices, and as much of the hows of building SaaS as we possibly can. Today is our final episode for this season, episode 10, and we have a tremendous guest with us today and a fantastic show. So let me start by introductions. So we have Damika Sriyananda, who is our senior solutions architect with SaaS Factory. Welcome, Damika. This is your second time on the show.
Thank you, Chris. Yes, this is my second appearance on the show. Great to be here.
Awesome. And a very special guest, the VP of Engineering with LendingCart. So thank you so much for joining us, Shivendra Singh.
Thanks, Chris, for having me. It's a pleasure to be here. Really look forward to the discussion.
Yeah, us too. And look, we've had an amazing season. This is the first season we've run this in this time zone, and we've had some spectacular guests on and some wonderful companies. And I'm so glad that we've got LendingCart on. So why don't we start the show, Shivendra? If you can talk us through for our audience, what is LendingCart and what do you do?
Sure. So at LendingCart, our primary goal is to provide working capital loans for MSMEs. MSME stands for like micro, small, and medium scale enterprises. So this is in a fully digital manner without any collateral. So there is a lot of, we have 4 different core products around this. One is by the name of Together, which is a retail lending marketplace product. One is Accelerate, which is a channel partner management solution / a distribution service that we have. And one is a Collectin, which is like a collection intelligence platform to collect the money back that we lend out. And the fourth platform is Credit, which is used for cash flow based on credit underwriting. So the Credit platform has been used to evaluate more than 11 lakh plus MSMEs, in which we have disbursed close to 250K loans through this time and amounting to more than 11,000 CR of in total. So this is really the backbone through which a lot of work gets done in multiple different products and platforms.
Awesome, thank you. Look, it sounds like an awesome company and doing some very, very, very important stuff for the market there. So this is the show about SaaS. So what of that is the SaaS centric nature of LendingCart?
Sure. So the Credit / the cash flow MSME underwriting, right? We really built it for ourselves, dating back to 7 years since the company is there, right? So we have built this platform. We have this large bunch of MSMEs that we have evaluated digitally, and there was a wide need in the market that people did not have fully digital credit underwriting service at their disposal. So
Right.
what we have done as part of this SaaS offering is that externalize that offering and enable it for different partners to sort of start consuming. So it's essentially a MSME credit score as a service, and what that means is we use AI ML models based on the cash flow, which is your banking data, and bureau data, which could be the bureau data for India. So we support all of those bureaus. So we look at a mixture of this data, and using AI ML models, we tell at the end what is the amount that you can lend to this person with what sort of parameters, and what is the default that you can expect. Typically, our customers are banks and NBFCs who do not have the ability and the means to sort of evaluate digitally and they have not seen through this kind of customers in the past, which is sort of this big.
Okay, awesome. Yeah, are we able to see? Can we see it? What it looks like?
Sure, would love to.
Let me put that up.
Bring that up. Yeah.
All right.
Cool. So this is what it looks like, and the way that we have designed this, right? I mean, there are a lot of customers who are very tech savvy for us. Then there are a few who are not that tech savvy, and we want all of these customers to get a feel of what our product is, right? You want to reach out to as many customers as you can. So this is a credit platform. It's a simple 3-step process, and some of the steps are optional as well. You upload your bank statement, which is really the cash flow data that you have. We support a wide variety of those formats here, and you upload the bureau data, and you can provide a reference ID that the partner has at their end, right, to be able to refer to this particular sort of case. And once that is submitted, then on a real-time basis, within 30 seconds, we'll tell the complete SaaS flow runs, and we tell a score at the end of it, which tells what is the risk, what are the defaults, what is it that we are expecting in terms of repayment for these years. And then we also share our IDs and the partner IDs to be able to refer to it both ways. So this screen is an offline view. Most of our partners do an API integration with us, so it helps them get started, and this sort of provides them a look and feel of something that they can quickly share, validate in their systems for some data, and then decide to do the API integration post this.
Well, I'm a little familiar with the LendingCard SaaS because the team I'm representing in AWS SaaS Factory, we help with the technology partners like LendingCard to build the SaaS solutions and go to market. So I had the pleasure of working with Shivendra and the team over time to help on this SaaS solution. And I know that there's a lot going on underneath this homepage that you can see over here. Shivendra, can you also explain us what is unique about this SaaS solution, let's say from functional or non-functional perspective?
Yeah. So the main is the reduced credit risk due to the AI/ML backed data science model that we have, which has been tested at scale. So we have seen through those MSME applications in which we have not only underwritten them, but we have also collected the money back from those accounts. So this is really critical for something in the lending domain, and this is data dating back to 7 years, in which you have seen through those cyclical business cycles and all that. That's baked into our model. The other ability is you had a large percentage of customers which are new to credit, which what we call as NTC customers, right? That they really do not have any bureau records because they have never taken any loans, etc., and then they are not present in the bureau, and that is close to 30% of the customers for us, and the model sort of caters to them as well, which is not possible if you are using just a bureau-based solution. So that's a lost business opportunity for a lot of our clients who are just using bureau-based underwriting. And the important piece is that it saves a lot of time and cost, because the manual process is prone to error, and then it's costly as well, and the customers are waiting. So this solution, the way that we have designed all of this, completes within 30 seconds for our clients, and it can be easily plugged into their real-time credit evaluation workflows wherever they need be. And so it helps them cost, and customer doesn't need to wait for anything, right? They use our model, they can tell them what their eligibility is.
Awesome. So the thing that we want to see now is what the architecture under the hood looks like. So I'd love for us to be able to go in to see what builds, what does this look like as you've pieced things together?
Sure, let me get that up.
Ooh, okay, let's see.
Okay, is it visible?
Yep, see that.
Okay, this looks quite detailed here, but I'll try to walk through and cover as much as I can. So these are our tenants who are our banks and MSME NBFC customers, right, who are interested in getting this evaluation done. the request comes to our API gateway, which is really all the public-facing interfaces are exposed through REST endpoints through this API gateway. That acts, it forwards this request internally, and we have used step function here to manage some internal sort of states for us, because we have some activities that will run in parallel, some will be sequentially and all. So we are using step functions to sort of manage. What we do here is that we use a custom authorizer Lambda function and Cognito user polls to be able to authenticate and authorize the user. So once that is done, there is a case ID generation Lambda function, which is responsible for taking the input data and essentially storing all of those attributes in a DynamoDB database. It's processed that while we continue with the rest of the evaluation process. So that's step one of the process. At the end of it, it has a case ID. The second, post this case ID, the second leg is we run some validation lambdas to ensure that the data that we want is in the required format, and otherwise we relay back those errors to the clients because they would be testing stuff and all that. So this is the validation lambda that makes sure that it's in the exact format that we want. And then post that, if it's there in the right format, we go ahead and we generate variables. So there is a whole bunch of variables that are generated, which is consumed by our models internally. So these variables are based on banking as well as the bureau. So based on the data that we took, more than close to 500 variables we are generating for this each of the cases. And then that again gets fed back to and updated to DynamoDB separately. What we do post that is we are using DynamoDB streams. A lot of this mechanism is async in nature. So if there were validation failures, we are relaying it back to the customer so that they can act on it. If not, it processes, and then it through DynamoDB streams, we come to know that the variable generation process has completed well. And post that, we call the Lambda, which interacts with our data science models that are hosted again within the same account. So here, the Lambda evaluates, talks to the model, and then gets an output data, which is essentially those attributes that we talked about, like what is the duration of the loan, what is the risk score, what is the bad rate, and things like that. So those output data is then persisted back into the same DynamoDB table. So the transaction is really complete at this point from that API. Now there are two modes that our customers really use it for their use cases. One is that some prefer waiting for a period of time because we guarantee like it will complete in 30 seconds. So some prefer waiting, and then we have exposed like a status and output data. So based on the ID that they relay to us, they can continue to poll even before that, and we'll tell that it is in progress. Once it completes successfully, it provides the output data along with that API. So this is exposed to them via an API gateway in which they can continue to call those transaction APIs, and then they will receive the output data once the process is completed, post the it is done. So this is a pull-based approach that most of our clients use. We also have a push-based approach in which once the processing is complete, we have a Lambda trigger, which then updates this information through SNS notifications through which tenants can be subscribed depending on what their use case is. And then it could really be calling their webhooks and all that. And then the real-time flow starts from there. So this is these are the two modes in which they are using.
Right.
For us, once the transaction is completed, we really don't need this data to be persisted, because post that we require the data only for metering or some analytical use cases and things like that. So what we have done is that once it is fully completed, we run an archival service which pushes the data from DynamoDB to S3 which are again tenant-wise buckets policy we have created. So each tenants have separate buckets created for them, and this archival process then is used. This S3 bucket is then used through ELK dashboard for a lot of different purposes. One is for our internal health checks and monitoring, some metrics that we want, and metering stuff as well. And thirdly, to even power our dashboards, which provides this intelligence to our clients. So they are interested in those granular details. So they have the ability to download, capture, and then do a lot of those transformations on this data. So we are not really calling DynamoDB or any of the other systems. It's all getting powered through this.
Right.
Lastly, here, we also don't want this data to lie continuously in S3. So we have a long archival process running, in which we push this to Glacier once this period is over.
Yeah, thanks for the detailed walkthrough of the architecture, Shivendra. Is there a specific reason why you had to choose serverless technologies and specifically on AWS for your SaaS solution?
That's a good question. So why we haven't done SaaS to be, I mean, we haven't done truly SaaS ourselves at that point. So when we started working on this, right, there was a need in the market. And then what we were looking out from our use case perspective was a proven solution, right, which was multi-tenant by design. And that can be scaled very easily without requiring a lot of developer bandwidth. And keeping our initial TCO, which was the total cost of ownership, very low initially, because a lot of our clients would be like, we wouldn't be charging them upfront, right? We'll give them like extended period of usages, etc., and then we want them to test it as it is. And we also wanted the flexibility that we could really put this solutions within their own infrastructures, right, within their own cloud solutions in the past, and a lot of customers were using AWS. So this was one reason. So we looked at something which sort of was able to cater to all of this. We reached out to AWS because we had engagement with AWS teams, right? So there was a AWS SaaS Factory team. We reached out. They also helped us on the GTM the go-to-market strategy, which was on the business side, and particularly on the technical side, like Dhamika and their team helped us make sure that we were architecting this the right way. And I think we had those help available at our end. And with that comfort, we decided that we'll go ahead with this.
Right. In your architecture, we can see that you're using the Lambda microservices for hosting the business logic. Is there any specific reason that you choose Lambda as a microservice? Is there any transition to Lambda that you had during your SaaS development?
Yeah. So traditionally, we are like a microservices. Like we have a whole bunch of microservices internally, which our internal products use. This one was a multi-tenant sort of SaaS offering. So our clients will continue to have varied workloads. Their workloads really vary a lot. And we wanted no upfront infra provisioning with minimal DevOps overhead, because we did not have any DevOps person sort of working in our team. This was a small team of few engineers sort of working on this product separately. Our focus was that the scaling should be sort of taken care by default as part of the initial design, so that we don't have to architect anything once we reach significant scale. So, and we did not want to sort of struggle through some of the challenges that you continue to struggle in the traditional microservices world, in which you will have to spend time just getting it to scale. We wanted to continue to work on the business side and sort of make sure that the feature delivery was done while we continue to get the client feedback. So the Lambda-based microservices sort of fit the bill for us, and it ticked all the boxes.
Great. I think that's a great story. Most of the SaaS providers who are actually building SaaS, they're leveraging Lambda like microservices for the same reason, and also, things like easy pay as you go model with the Lambda, and also not being able to handle the servers anymore underneath, and those kind of reasons. It's great to know that you have adapted the Lambda for similar reasons. Given that the use cases with heavily regulatory industry and dealing with a lot of requirements like that, how can you talk a little bit about how have you achieved the security and the compliance of the lending card SaaS solution?
Definitely, this is one of the things that is most critical for us. The reason being that most of our clients are banks or big NBFCs in which data security is of utmost priority. So uh, primarily we rely on AWS best practices. We already have some of those systems like Trusted Advisor and few of those other things, etc., that we run on top of the system. So we do that any which way. And additionally, we worked with the AWS SaaS Factory to decide what is the best way in which we can take care of the tenant isolation. This was really key to ensuring that as an architecture, the tenant isolation ensured that there is no access to any other tenant data at any stage. So what we have used is a hybrid pooled model for us. This is the tenant isolation model that we have selected, which is key to our security. Uh, the hybrid pooled model is essentially a mixture of siloed plus the pooled model. Most of our clients are on the pooled model, and the bigger clients can be put in the siloed architecture. So they don't have to worry on the siloed architecture, but the ones on the pooled model, by design, we have taken care of some of the changes which we can cover later in terms of making sure that one tenant's data is not really available for the other tenant at all. So that is sort of taken care within the access control mechanism that we have put in place. And also, uh, we wanted to make sure that this was a separate AWS account both for us as well as for bigger clients. So we ourselves are an NBFC, and a lot of banks and customers will have apprehension that uh, are you sending data to your own systems, right? And will you use it to sort of judge our clients? And obviously we had to showcase that, so we did some audit, etc., and ensured that this account is really secure, and then you have the ability to put it up on separate AWS accounts if need be. So that give the confidence to our clients that security is taken care, and none of the data is going outside to any external system.
Awesome. Yeah, that's good to hear. It's clear that you've thought through all of that sort of stuff. Particularly when we talk about architecture, and there's a lot of moving parts here now, and you're in an industry, particularly finance, where this becomes very important. Do you have SLAs? What are the performance aspects of what you needed to build here?
Yep. So one is the main SLA that we have is the predictability in generating the credit scores, because the clients are waiting on a real-time systems, right? And they don't want to wait for long. But however, the modeling, etc., that it's run, it's very compute intensive, right? There is a lot of data crunching that happens. So taking into account what we have said, and we iterated initially, it was taking around 60 seconds. We did some optimizations and we came to 30 seconds was something that we were able to cater to despite the workload. So that is something that we are maintaining as an SLA, and we also sort of have error budget monitors to ensure that we are not breaching these SLAs for our clients. So this is a P99 latency for all the paying customers that we sort of continue to maintain. And we also track the error budgets to ensure that it's not breached, and we have not seen instances of this getting breached yet.
Right.
And the one other aspect is that in order to achieve higher these SLAs for our critical customers, because some are more important than others. So everyone might be paying, but you have like the one big client who is your most important customer. So
Sure.
we have using the siloed model in which everything is set up in a different AWS account, and that is not prone to the noisy neighbor problems which you typically get in a
Right.
cooled sort of environment. So that's also supported and can be used.
So look, every time we talk about SaaS, tenancy is always clearly a big deal, the biggest differentiator. So with the system that you've got here, how do you understand your tenant usage? What are they doing? And where is the load on each part of the system?
Right, that's a good question. So what we have built here is that we have built. Uh, uh, can you see my screen, Chris?
Yeah, yeah, yeah.
Yeah. Okay. So we have built a lot of business intelligence on top of the transactional APIs, and that is really the crux of it, in which it gives not only us, because we have to maintain the SLA and the monitoring and all of that, but our clients get to see all of that data for their use cases, and then they can do a lot of these things. So what we have used on the technical side is that we have used ELK stack, to power a lot of this. So the data is going to S3, which is per tenant buckets created, and we have individual tenant-wise indexes created in Elasticsearch, which sort of cater to all of this. And this is then used to power this business analytics use case. And as you can see here, clients and the tenants have the ability to, they can search it by what happened to this particular case, right? They can just type it here, and then they will be able to see the status, why it failed, those regions. There will be like validation error, then what is this, all that bifurcation is available. They can also filter by specific dates. They can filter by what is the output also, like they really want to evaluate what are the better customers versus not so good customers, and then they can download a bunch of this data for their particular use case, individual basis or on bulk basis. So and then they can do a lot of this crunching. All of this is completely used using the ELK stack itself.
Oh, lovely. Yeah, that's an awesome solution for that. So let me move on with something slightly different as well. So, and you touched on it prior. So you work in a essentially in the financial space. There's a lot of regulation. There's a lot of expectation as well, particularly around data and security. Now, when we go and we always ask for let's look at code, let's look at a demo. What would be great in this instance is to start to look at code for how you implemented some of this security or isolation. Would be awesome to look at this point.
Sure, would love to. Let me present something. So what we do here, Chris, is that we have tenant-wise data isolation. Our data store is DynamoDB that we are using for our use case. So we have a very fine-grained access control through DynamoDB that ensures that the tenant isolation is maintained throughout the application layer. So I'll can show up a quick demo, which will sort of showcase that how we have done it. Okay. So let me know if my screen is visible.
Yep.
Yeah. So this is obviously we can't show the real production data. So we have created something which is sort of highlighting that. So we have like two tenants here, tenant 1 and tenant 2. And then they have different sort of IDs and a whole bunch of different data that these tenants are maintaining. So what we'll show is that how are we ensuring this both in terms of get as well as post APIs, right? When you're reading data and as well as you are writing data. So let's see how. So this is version of what we use internally. And if you can see, let's see, we had populated this data ourselves. So let's see a get system. Okay. So here, the tenant one is trying to access tenant one data. And this is a get operation. We'll go to the code part post this. Okay, let's run it. So it received a response. As you can see, the tenant one, the data that we requested here was for tenant 1.5, so it has received that particular detail here. Now we will try to, let's say, we try to access the tenant 2 data from tenant. Yeah. So let's say tenant 2 is trying to access the tenant 1 data. Okay, so here you go. You cannot access, so irrespective of what code you have written, right? I mean, as an architecture, you cannot access other tenants' data anywhere. And yeah, we can. I can go into the code walkthrough for this really quickly. One sec. Let me bring that up. Yeah. So here's what we are doing. So if it's a get operation, which is what we were using, we are getting the DynamoDB tables, which is scoped by the tenant ID. So we pass the tenant ID context here. So so let's look into the details for this. So here, what we are doing is that we are providing, I mean, we pass the tenant ID as a policy, and then the policy is something that I can just quickly showcase here. So again, we have a regex to sort of provide, it has to begin with this tenant ID, and then we replace it with the actual tenant ID that is getting passed. So, so we create this role, and then within this, we look at the credentials object. So now this credentials that we have created can only has a temp access to be able to look at this tenant ID data, and it can't really access anything else. So suppose that we go ahead and view this. So basically we are assuming the role and we are extracting the credentials, and then the Python session is really using that to limited scope. It is trying to access the data. So if you have the access for that particular tenant, you will be able to access. Otherwise, you will get an unauthorized error.
Right.
Yeah.
I think it's a very powerful feature, fine-grained access control aspect using IAM policies, where you can dynamically create these policies with the tenant information and then assume a role that has a full database access to the DynamoDB table, and trim the permission specific to the tenant. So using that connection to the database, the tenant one can only see the dataset related to the tenant one, and when try to do any operations related to any other tenant, it will throw a access denied exception. Also, just one of the things I want to kind of highlight in this aspect in here is that if you look at the DynamoDB table that Shivendra presented, the way the tenant ID has been represented is different. So we are not using the tenant ID as is to represent in the DynamoDB table. There's a specific reason for this. We call it a hot partition issue when you use a DynamoDB table. Yeah, in order to kind of explain that, Chris, would you be able to just share my screen for a real quick so that I can actually, I have one diagram to just go through that. Yeah, thank you. So generally what happens is if you want to share a DynamoDB table across multiple tenants, you're gonna go ahead and use the tenant ID as the partition key of the DynamoDB table. The importance of this partition key is that internally DynamoDB will use the partition key to decide where the data has to be put in which partition at the storage level. So if you use the tenant ID as a partition key, it will send it across a hash function, internal hash function, and then based on the output, it will decide which partition inside DynamoDB that the data has to be stored. So essentially, if you use the tenant ID as is, all the data related to one tenant will be within one partition. And based on the way that hash function works is for unique input, it will kind of categorize the output. That's what hash function does. So which means that there is a chance that the one partition will be hosting multiple tenants as well, like in here. So when this happens, if one of the tenants will get busy, which means if one tenant needs more read capacity units and the write capacity units for the operations, it can easily becomes a noisy neighbor or noisy tenant, which will make the whole partition a hot partition, which needs significantly higher read and write capacity units. So that will affect the IO operations of the other tenants that is in the same partition. So this is the kind of a design consideration when you want to share a DynamoDB table across multiple tenants. We call it hot partition scenario. So in order to prevent this, we strategically need to distribute the data set of a given tenant into multiple tenants, multiple partitions, in the DynamoDB, within DynamoDB. So in order to do that, instead of having a tenant ID as is, we can add a postfix, which is a kind of a random number. In here, I have used a random number between 0 to 10. So then, even though we are representing data from the same tenant, we are actually having a different value for the partition key. So that will kind of result different partitions through the hash function to store these data in different partitions. So basically what we're trying to do is to distribute this data set across multiple partitions. So even though if tenant one becomes a noisy neighbor, the impact would be minimized. So based on like how much read and write operations you may need for your noisy neighbors, you can select how you can model this postfix number, and then use that as a mechanism to overcome this hot partition issue in DynamoDB Disciple. That's why we have the tenant ID stored like this in the table. So one of the design considerations, if you're expecting any noisy neighbors when you go live in your SaaS solution to decide.
Lovely. Thank you, Danica. Shivendra, so you showed us the get. Can we see how you do the put?
Sure. Let me show that.
Switch.
So, yeah. Cool. Yeah. So this was a put that we did. We put from tenant one in shard one. So there was already one. I think there will be two now. So it succeeded. Let me try putting something from another tenant. So it's a tenant two is trying to put something in tenant one. Okay, so there is an exception, and that was not allowed. The code is pretty much similar to what we covered in the get part. And again, we get the tenant ID scope, and it's just that the roles will be slightly different and the access permission. it assumes that role, and then those credentials are the template credentials are getting used for that IAM policy.
Right. Okay, lovely.
All right. So just let me add one more thing here. So if you like in a typical SaaS solution, if you want to kind of maintain these IAM policies in a static way, you're going to have different IAM policies per tenant, per resource basis. And going forward, it's not going to be a scalable solution. So the best practice would be to kind of dynamically create the IAM policies based on the scenario, based on the tenant and the resource. So ideally, what has to be done is to kind of parameterize these IAM policies and use a kind of a templating engine to select the IAM policy and then inject the details like the resource ARN and the tenant ID, as you can see in the screen, to kind of dynamically generate that portion and then inject that to the workflow. And if you want to further make the solution scalable, you can build a kind of a separate unit or separate microservice for that will basically take the tenant ID and the other information and provide the credential object to you, so all the microservices can reuse that. So we one of our architects has done a really good blog post around this in dynamically creating the IAM policies using a token vending machine. So we can actually share that link on the chat as well for anyone in the audience to have a look. So that way you can actually have a very scalable mechanism in your SaaS solution. So you don't end up maintaining a lot of IAM policies. You just hand over that to a separate unit to get either the credential object itself or even the database or the client object to connect to the DynamoDB or to the S3 client, S3 bucket, based on the resource that you want to access. That could be another best practice on top of this implementation.
Shivendra, so I was sharing the wrong screen. I thought I did change it. Can you go back to that put example again, just while we're there?
Yeah. Yeah. So this is the put code, and it's similar to what we had for it.
Okay, lovely.
Again,
so essentially the put method is also using the same workflow where you have the similar similar way it takes the credential object and kind of use that object to generate the database connection, so that even when you are saving, if you are on tenant 1, you can save the data with the tenant ID of tenant 1. Otherwise it will throw a access denied exception.
Yep.
Awesome. May I also ask a question about the Lambda layers, Shivendra? So first of all, are you using any Lambda layers in your SaaS architecture, or is there
yeah, we do.
Yeah, and is there any generalization of this approach that you can kind of recommend to do better in terms of Lambda layers when you build a SaaS with serverless technologies?
Right. So we are using this generation of temporary credentials per client functionality. So we have put this into a Lambda layer so that all the different Lambda functions, right, can be access it and reuse it. And this is also getting used for tenant-aware logging that we are using and for our monitoring. So we are not sort of doing that within each of the Lambda functions. This is externalized and then provides us a seamless view to ensure that all the Lambda functions are uniformly doing it. And that's how we are using it so far.
Nice. For anyone new in the audience about the Lambda layers, we can actually generalize the common functionalities into Lambda layers and let other Lambda microservices to kind of reuse these components as like libraries, for example. So you kind of don't repeat the same functionalities or the same implementation in multiple places. So it's a very efficient way of organizing the coding and also distributing the functionalities across Lambda microservices using Lambda layers.
Nice. Now we've got a bit of time on our hands, so there's a couple of very SaaS centric questions that I want to ask as well. So Shivendra, the particularly for anyone building SaaS, you're always looking at who is your customer base now, who will it be in a month or 3 months or a year or more. So for what you've built, what sort of scale are you targeting at this point, or what have you built for?
So we have a lot of varied workloads, as I talked about, but what we have tested and we have ensured that 1,000 concurrent requests, the system works as it is. There are no issues. And this is without doing anything to sort of manage that the infrastructure, right? No DevOps, no auto scaling policies and things like that. So it works for 1,000 concurrent requests. Given our workload, we don't anticipate it to being more than that in terms of the concurrent users. So,
okay, that's a good number. And in building this, what was the main, particularly for the SaaS portion of it, what was the main challenge for you, or what was the most difficult one?
So that's something that we are still sort of working through in the subsequent phases. So the primary challenge that remains for us is that a few of our customers, we need to do this inferencing at the edge. What that means is that our models, etc., and everything will remain within the customer's premises themselves, and then they are not even using public clouds of any sort. So how do I ensure that my models worked at scale with those SLA guarantees without getting them into this SaaS architecture? Because I mean, I can put them in a different AWS account, but then that's also not something that they want. So this is something that we are sort of working it, and it's next in our roadmap. Interesting problem, I think.
I think certainly it's an interesting problem. We see more and more customers actually getting into this model of hybrid SaaS solution development, where when your use cases are really driven by the latency or the compliance and those kind of non-functional requirements, sometimes you cannot have the full data of the customers on the cloud. So in these situations, one of the approaches would be to bring a remote component of your SaaS solution into the customer environment. So that way you basically kind of extract a portion, maybe a couple of microservices that really does the data processing and the remote centric operations from your application plane, and then put that as a remote workload into the customer environment. So when I say customer environment, it could be a VPC on-prem, or it could be another AWS cloud, AWS account where the customer data is residing, which cannot be taken out, right? So because of the latency or the compliance issues. So that way you have a component or remote component residing in the customer environment, and then you have some handshaking mechanism to integrate with the application plane in the cloud, which is your main SaaS solution, and you still operate using the tenant ID. So there are multiple things to think about when you're building a hybrid solution like this. How do you distribute this remote component when the tenants are onboarded, right? So, for example, you may have a standard installer distributed for the ones who are getting registered with you, so that they can actually install that in their environment, and then there can be some handshaking happening to register with the tenant ID, and then you can let the remote component to the meter the matrix and do all the processing that should be done within that scope, and then get only the data that can be exposed to the cloud, and then work with your control plane and the application plane for the rest of the work in your SaaS solution. It's pretty interesting topic, building this hybrid SaaS solutions, and then I'm really interested on this aspect. Actually, I'm hosting a reInvent session this year in about a couple of weeks in the same topic, building the best practices and architectural designs in building hybrid SaaS solutions. It's called SaaS Anywhere.
Awesome. Get that plug in for reInvent.
Yep.
I'll be watching. I will absolutely be watching. So we are quickly running out of time, but there's one last question, Shivendra, which I think is an important one. And for the audience that is looking to build SaaS, particularly on serverless, what would your advice be? What are the big things to look out for?
So this is based on our experience so far working with AWS SaaS Factory and how we have been able to build. Initially, I mean, for us as well, there were apprehensions because we have not done SaaS and then we don't have a big team to be able to support. So I think those apprehensions, with the help of SaaS Factory or somebody who is an expert, if you have the availability of those people, then those apprehensions are sort of taken care. Along with that, I think there was some boilerplate solutions that were existing in the language of choice. So we use Java. We had Java. There's Python implementation and whatever it is that the teams are using. So there is that boilerplate code to sort of get you started, and then there is a community support and obviously the AWS team. If you get stuck with something, they have the expertise to be able to help you and unblock. So our core theme is, when you are building SaaS products, you want to focus on building the product because you're looking at finding that initial product market fit, right? And you initially do not want to worry about the scale or the cost or the infra and the provisioning and things like that. That's really for later once you have got the fit and sort of working. So I think it enabled us to sort of focus more on the product than on the other aspects which we needed to. We had the infra and everything ready for us whenever we required. And we also did not, it lets you not struggle with some of the challenges that you face in traditional microservices, right? What if there is a downtime? You can't afford a downtime in a SaaS solution, right? Yep. So traditional microservices, you have to sort of spend some time to be able to make it and also scale. So all of them are by design enabled. So it helps a lot that the team is able to just focus on getting the product and building it and getting that validation from clients and then incorporating that feedback loop into the product.
Yeah, awesome. Look, SaaS is hard, and we are trying to do everything we can to try and make that easier for companies like LendingCart and other customers. It's one of those ongoing journeys that you're always looking to improve, and there are a huge amount of supporting structures that AWS has in place, not just infrastructure, but services like SaaS Factory with Dhamaka and others. So look, we have got to the end of our time. Thank you so much for tuning in. Thank you incredibly, Shivendra, for your time and for introducing us to LendingCart and the amazing architecture that you've got, that you've put forth here.
Thanks a lot, Chris. It was lovely interacting with you and Dhamaka.
Yeah, it was super informative. There's a lot of education here. There's a lot of knowledge here, and also thanks to Bill for being so quick to get those links out on the chat. Dhamaka, always a pleasure. Thank you so much for adding your expertise onto the show as well.
Thank you, Chris. Thank you so much, and thanks, Shivendra, for being with us. It's an awesome discussion. Thanks.
And thanks for everyone for tuning in. This is the last episode for this season. We will be back. The plan is absolutely to come back next year for season 2 of Building SaaS on AWS. But until then, feel free to ask us questions or get in touch. We'd love to hear from you. But until next year, thanks everyone, and see you next time.